Hey guys, all right, today we're going to be talking about scaled figures related to volume. Okay, so if we remember way back when last semester when we were talking about scaling figures, if we multiplied by a whole number, that figure got bigger, or each side got bigger by that amount. If we are multiplying by a fraction or our our scale factor was a fraction, our figure was getting smaller. Before we get into that, let's go ahead and go over the warm-up real quick. So this is from our lesson from Monday. So finding the volume of a right cylinder cone. Okay, so we would need to find the equation for a cone, which is volume equals 1/3 times pi r squared times height. Okay, so first I need to find what my radius is. Well, we are given our diameter of 3.4. And if you remember from Monday, radius is half of that. So I'm going to plug that in divided by 2. So I've got 1/3 times pi times 3.4 divided by 2 squared. And then our height is 13 meters. So that times 13. You're going to plug all of that into Desmos. Where's pi? 3.4 divided by 2 squared times 13 should give us 39.34. We are rounding our answer to the nearest tenth. So the volume of our cone should be 39.3. Okay. If you have any questions, write them down so I can answer them tomorrow. All right, so today we're looking at volume, like this should say Monday, like Monday. We need to find our total volume, then multiply or divide by our scale factor. Volume, scale factor, image, and pre-image are the terms that you need to understand. Unlike Monday, where our scale factor was one-dimensional, volume is three-dimensional, so we can scale by K, which is our scale factor, cubed. Okay, so for the district assessment next week, the most important thing is for you to understand how the scale factor is going to affect your overall volume. Okay, so below we have a figure that is dilated by a scale factor of 3. Find the volume of the solid creating upon dilation. Okay, so first, what I want to do is see what the volume of our original factor is. Okay, so our shape is going to be a triangle, base, rectangle, height. So we're going to do 1/2 times base times height of our base times the height of our whole image. Okay, so I'm going to have volume is equal to 1/2 times base times height, that's of the triangle, then times height of our whole image. Okay, so we're going to have volume is equal to 1/2 times, what's our base? Okay, so I'm going to say 9 times our height. I'm going to say 7. And then the height of our whole image is 4. Okay. Okay, go ahead and multiply that out. So now I would have 1/2, or let's just put it into Desmos. So 1/2 times 9 times 7 times 4 be 126. Units cubed. Okay, now it says we are going to dilate our image by 3. Okay, so if I multiplied all of my sides by 3, okay, all 3 sides are being dilated. Therefore, now my new image would be 3 times bigger than this, right? So my new base is going to be what? What's 9 times 3? Be 27. 7 times 3 be 21. 4 times 3 would be 12. Okay, so we're going to multiply that. Which would give us 3,402 units cubed. Okay, so notice my volume of my pre-image or my original image is not just 1/3 of our new image, right? Or our scaled image. So if I took 126 times 3, that would be 378. That does not match what my new image is, right? So since this is a 3-dimensional shape, my whole shape or my volume of my shape is actually changing by a scale of 3 cubed, since all 3 of my sides are dilated. Okay, so 3 cubed is actually 27. So 126 times 3 to the 3rd power is 3,402. Okay, so what happens to the volume of my shape? So it increased by 3 cubed, where 3, my base, is my scale factor. Okay, questions on that? Okay, just pause this if I go too fast and you guys need more time.